Hello everyone, welcome to solve this nice math or Olympiad algebra problem. So here we have square root of m is equals to minus m, and we solve this problem for all the values of m. So here first we need to find all the roots of this equation, and at the last we will be verify that which of the roots are solution and which of the roots are extraneous root. Further we solve this problem for two methods. I hope so you like both of these two methods, but if you have any other method in your mind, so please don't hesitate to write this method into the comment section. And now we move toward the solution of this problem from first method. So here in the first method, we just take a squaring on both of the sides in order to remove the square root sign. So when we apply squaring, it will be written as square root of m and its whole square is equals to minus m and its whole square. And further in the next step, we have these two and square root are gone, and we get here m is equals to, here you see that this is the square of negative m becomes here positive m square. And now here further in the next step, we move this m to the right hand side, and it will be written as m square minus m, and this whole equation is equals to 0. And further in the next step, you see here both of these two terms involve m, so that we will be take common m from here, and when we take common m, we get the remaining values are m minus 1, and this whole equation is equals to 0. And now here further in the next step, we need to divide this equation into the two cases. The first case is we write m equals to 0, and the second case is we write m minus 1 equals to 0. So this is the first root of the given equation, and from here we get the value of m is equals to plus 1, and this is the second root of the given equation. So from first method we get these are the two roots of the given equation, and now here in the next step we need to verify that which of the root are solution and which of the root are extraneous root. So for verification of these roots, we need to copy down given question statement. Here it is square root of m is equals to minus m, and in this side we will be verify m equals to 0, and in this side we will be verify m is equals to plus 1. So we need to verify both of these two roots, and here first we verify m equals to 0, and when we put m equals to 0 into the given question statement, it will be written as square root of 0 equals to minus 0, and you see here this will becomes 0 equals to 0. So this shows that both of the sides are equal, and if both of the sides are equal, this means that the value of m equals to 0 is satisfied our given question statement. And now here in the same pattern we need to verify the second value of m, and here we just substitute m equals to 1 on both of the sides, and it will be written as square root of m is equals to minus 1, and here we easily get 1 equals to minus 1. So this shows that both of the sides are equal, not equal. So if both of the sides are not equal, this means that the value of m equals to 1 is not satisfied our given question statement. So this shows that the value of m equals to 1 is not satisfied, and we conclude about m equals to 1 is that m equals to 1 be the extraneous root of the given equation. Okay, so this is the extraneous root because it does not satisfy our given question statement. And finally we have the solution set of this problem is m equals to 0, because m equals to 0 is satisfied our given question statement. And now here we need to move towards our second method. So in the second method, here first we copy down given question statement here, so that our given question statement is square root of m is equals to minus m. This is our given question statement, and here I can again solve this problem for another technique. So here first we move minus m from right hand side to the left hand side, and it will be written as square root of m plus m is equals to 0. So here you know about that if we have any value of m, then this means that if you have any number a, we write this a into the form of product of two radicals. We write it as a equals to square root of a multiplied by square root of a. Okay, so according to this rule, we write this m as in the product of two radicals form. Okay, so it will be written as square root of m equals to square root of m multiplied by square root of m is equals to 0. And further, in the next step here, we need to take common square root of m here, and when we take common square root of m, we get the remaining values are, this is 1 plus square root of m, and this whole equation is equals to 0. And now here further in the next step, we need to divide this equation into the two cases. The first case is we write square root of m equals to 0, and the second case is we write 1 plus square root of m is equals to 0. And further in the next step, you see here we need to find the value of m. So for this we take scaling on both of the sides, and when we apply scaling on both of the sides of this term, it will be written as this 2 and square root are gone, and we easily get the value of m is equals to 0. And in the same pattern, we need to find the other roots of the given equation. So for this we move this plus 1 to the right hand side, and it will become the square root of m is equals to minus 1. And uh, here in order to remove this square root sign, we again take a squaring on both of the sides, and when we apply squaring on both of the sides, it will be written as in this form. So this 2 and square root are gone, and we get here our m is equal to, this is minus 1 square, and minus 1 square becomes here plus 1. So this is the value of m equals to 1, and this is m equals to 0. But in the first method, we already verified that m equals to 0 is satisfied our given question statement, and m equals to 1 is not satisfied our given question statement. So we call that m equals to 1 be the extraneous root, because it does not satisfy our given question statement, and m equals to 0 is satisfied our given question statement. So we call that m equals to 0 be the solution set of the given equation. So this is the final answer, and thank you so much for watching this video. Please subscribe to my channel for more exciting videos.